Okay, so last unit we talked about arcs. Okay, somebody describe to me what an arc in a circle is. Just like in your own words, what's an arc? Yeah, like the outer ring, right? A little portion of the outer circle. Okay, what about the central angle in a circle? The little angle from the center point of a circle. Beautiful. Okay, well now we're talking about chords in a circle. Okay, we'll get to that in a minute. The first few are just review from what we talked about last time. Okay, but that's going to be our new word of the day, a chord in a circle. Okay, so let's go ahead and just jump right into numbers 1 and 2. What are we asked to do for numbers 1 and 2?
And the circumference of each circle.
Alrighty, okay, so let's remind ourselves what our two circumference formulas are. They're up on the board, but always good to have them written on your paper so when you are taking a test, you'll have them. Their circumference, you can either use the 2 times pi times your radius formula, or if it gives you the diameter, you can use pi times diameter. Two options there. Based on what it gives you, use the easier one. Okay? Awesome. So, what is it giving me for number 1? My radius or my diameter? The radius. Good. The radius is from the center point to an edge of the circle. Okay, so my radius equals 6 yards. Which formula do you guys want to use, 2 pi r or pi d?
What?
Which one? The first one, right? Could you use the second one? Could we figure out what the diameter is from the radius?
Yeah.
You could, but why would we want to do extra, right? Gives you the radius, let's just use that guy. Okay, so that means to find our circumference, we're going to have to plug in 2 times pi times my radius of 6. Okay, this is where you're going to want a calculator because we have our pi button. So I have 2 times pi. I like to put whatever I'm plugging in the parentheses. That just means I plugged something in. Times 6. Okay, let's practice rounding it to 1 decimal place. 1 decimal place. What's this going to round to? 37.7. So the circumference of this circle, 37.7 what? Yards. Remember, whenever we're measuring something, we want the units. Okay, that tells us how big this circle actually is. All right. Still trying to find the circumference for number 2, but this time what does it give us? The radius or the diameter? The diameter. Could we use the one with radius?
Yes, it would be 12.
Nice, Kristlyn. It would be 12, but why calculate something extra? If it gives us the diameter, let's just use the formula with the diameter.
Wait, so I have a question.
Yes, sir.
On the first one,
Uh-huh.
could we do diameter, just make it a 12 though?
Yeah, absolutely. Just get rid of that 2 and make it pi times 12. Because isn't 2 times 6 12?
Steps, right? So it'd be faster.
Whatever works in your brain. If you like it that way, go for it. Okay? So for this guy, I like just plugging in what they give me, right? So they gave me the diameter. I'm just going to take pi times my diameter of 24. Okay, what'd you guys get? Pi times 24.
7.6. So 75.4.
Beautiful. Love it. Okay? 75.4 is our circumference. 75.4 what? Miles. That's a big circle.
Dude, you don't divide.
Cool.
So dumb.
Okay, so again, whatever it gives you, you get to kind of choose which formula you plug it in for.
That's pretty cool.
Cool. Okay, number 3. This is where we're going backwards. What are we trying to find here? It says find the what?
Area.
Oh, for number 3?
Oh, for number 3, the diameter of each circle.
Good. Okay, so it wants us to find the diameter. What's it giving us?
The circumference.
The circumference, okay? We already know what the circumference is. We're not solving for the circumference like we were just doing. We're going backwards. So this is like number 2 on our starter, okay, where we know that the circumference is 32. So we say 32 equals, if I'm trying to find that diameter, which formula should I use? 2 pi r or pi times d? Pi times d. Okay, 32 equals pi times d. I don't know what d is. I need to solve for d. How do I get that d by itself?
Divide pi.
Good job. This is like saying pi times the diameter. So to get rid of times by pi, we divide by pi. So in, what is it?
It's 10.2.
32 divided by pi. You got it, 10.2. Look how good you guys are at rounding. 10.2 what? Remember, we want the units. km, not km squared. Nope, not solving for the area, just solving for a measurement here. The diameter is 10.2 kilometers, or kilometers, however you say it. Cool. Alrighty, fist to 5 on circumference. How are we feeling about that guy?
4.
Cool, love it, love it. Alrighty, numbers 4 and 5, what are we finding now?
The area.
The area. Okay, there is only one option for your area formula. Okay, so our area formula, remember our area equals pi times your radius squared. Sometimes it's nice and it gives you the radius. Sometimes you gotta actually figure out what the radius is because you can only plug in the radius. You cannot plug in the diameter for this one. Okay, for number 4 though, what is it giving us? Radius or diameter?
Radius.
Radius. Okay, that's super nice. Okay, so we have pi times my radius, which is 3 squared. Oh, that was super nice. Punch that in your calculator. Pi times 3 squared. And what do we get? Help me round this guy to one decimal place.
28.3.
Nice. 7 bumps the 2 up to a 3. So our area for this circle, 28.3 what?
Miles
squared.
Good job. We're talking about area here, so our units have to be squared. 28.3 miles squared. Cool. Okay, same thing for number 5. We need to use our pi r squared formula. Do we know our radius, or does it tell us our radius right off the bat?
No.
No. How do we find the radius if our diameter, though, is 6?
We divide it by 2.
We divide by 2, right? The radius is just half of your diameter. So if our diameter equals 6, then our radius would be 6 divided by 2, which is 3. Not too bad. Okay, but sometimes you do have to do that extra step of finding the radius. Okay, but now let's go ahead and just plug it into our formula. We know our radius is 3 now, so now I can plug it in. Pi times 3 squared. Oh my gosh, do you guys have to plug this in again?
No.
No. What did we just get for number 4?
28.3
Units? 28.3.
centimeters.
Nice. So these are definitely not the same size of triangles though, even though our measurements, or circle. Thanks, Crystal. It's almost the end of the year, right? So the area of this circle, 28.3 centimeters squared. Definitely different than miles squared. But if you notice you've already punched that into your calculator, why do it again? Okay, fist to 5 on area. Punching it in.
3.
All right, let's go backwards then. Okay, for number 6, what are we trying to find here?
The area.
Right.
We already have the radius.
Yes, we have the area. We're trying to find the radius. Okay, so this means, again, we are going backwards. The area of this circle is 201.1. It's okay, this is a decimal. Steps are still the same. 201.1 equals our formula, pi r squared. We need to get this r by itself. This is actually a 2-step equation. There's 2 things we need to get rid of. What do I need to get rid of first, the pi or the squared?
The pi.
The pi. Why the pi?
Because it's the farthest away from the square.
Are you sure it's the farthest? They both look pretty close.
But it's the farthest.
It is the farthest. In other words, think of it like this. Okay, when you are just like plugging something in, we follow PEMDAS, right? Order of operations. Okay, when we're going backwards, we go backwards in PEMDAS, which means we're going this way. Which one comes first when we're going backwards? The multiplication we got to get rid of, or the exponent?
Multiplication.
That's another way of thinking about it, right? You can say, well, I don't know which one's farthest, okay? Or you can say, well, which one would come first in backwards PEMDAS? But you're absolutely right. We got to get rid of that pi. How do I get rid of times by pi?
Divide.
Divide by pi. So that's my first step. So in your calculator, let's do 201.1. 201.1 divided by pi. And just to make sure we're as accurate as possible, let's take it to 4 decimal places. Okay? So let's see. 1, 2, 3, 4. The 1's not going to change it. So we got 64.0121. Okay? 64.0121. Okay, we like to take it to a few decimal places just to make sure we're as close to our answer as possible with rounding. Okay, and that equals r squared. We still have that radius squared over there.
Can you divide it by square?
How do I get rid of a square?
Did you get an email on this?
You divide
You
by
did?
itself.
Ooh, we're not dividing. That would be the opposite of multiplication.
That's-
Square root.
That's what I meant.
There you go. Okay, we got to get rid of that square by square rooting both sides. So again, just put the square root of this decimal in your calculator, and that'll give us our radius. Second button, square root, let's see, 64.0121.
I got it.
And what is my radius here?
8.
8. Is it okay to just leave it as 8?
Yeah.
Yeah, 0.000. Yeah, we're good. Our radius here is 8 what?
Meters.
Meters. The radius. Ooh, is it squared?
No. Center area? No.
Did we solve for the area though? Nope, we found the radius. I love that though. Okay, love that you guys are double checking. Do we need the squared? Do we not need the squared? Nope, this was not our area. This was just our radius. Nice. So we had to go backwards and solve. Okay, show me a fist of 5 on that one. Number 6. Going backwards and solving for the radius. Yep.
Also, can I borrow a charger?
Yes.
You need the flat one, I think?
Yeah.
There you go.
Thanks.
Alrighty. Okay, so here's where we get to our new concepts, you guys. This idea of chords within a triangle. Okay, so look at numbers 7 and 8. Okay, so let's go ahead and label some of these on our circle. What am I labeling right now? A central angle, an arc, or a chord, do you think?
An arc.
An arc. Okay, that right there, we already know what that is. That's an arc. Okay, what am I labeling right now? Central angle, arc, or chord? Central angle. That's the angle from the center of the circle. Central angle. Okay, here's where our new thing comes in. These guys right here, those are our chords. Okay, what do you notice? What shapes do we have inside of these circles?
Triangle.
Triangles. Ooh, we know lots about triangles. You guys know how to solve for missing sides of triangles. We know how to do that. Okay, so we are asked to find the length of this chord, or in other words, it's also a radius right here. Okay, and I want you guys to simply do some guesswork here. Okay, there's like no solving required for this problem. It does give you enough information to figure out what x is. Throw out an educated guess. Based on what it gives you, what do you think it is?
Is it 11?
It's 11, right? Because that is equal to our other radius over here. Okay, so we know that x equals 11. And that's literally it. Okay, they will get harder. Okay, so let's look at number 8. Again, do some guesswork. If it's giving me the length of this chord right here, it's not necessarily a radius, what do you guys think x is going to be? Throw out a guess. If that chord is 19, it's going to be 19. They're equal to each other, okay? Notice it kind of cuts it right in half right here. So if this side is 19, then that one also equals 19. They equal each other. Easy peasy. Alrighty, that was way too easy. Let's take it up a notch. Okay, turn your paper over. Ooh, okay. Now we're taking it up, right? So we're asked to find this side right here, this x side right here, missing side of a triangle. Okay, tell me, you guys, what's one theorem that we've practiced a ton this year to find a missing side of a Pythagorean theorem? Okay, we're probably gonna have to use that, so let's put it on our paper. Pythagorean theorem helps us find missing sides of right triangles when we know two of the sides. Okay, remember it's a squared plus b squared equals c squared. Do we know two sides of this triangle though? If it's, I'm just looking at this triangle right here, including that green side.
Yes.
We do. I know that 12.8, but what is this side?
90 degrees.
Good. 90 degrees?
No,
9 point.
9.8.
Beautiful. Okay, so that's where that idea that we just talked about is that these are equal to each other. Well, if that's 9.8, we know that's also 9.8. Can we find that missing side of our triangle using Pythagorean theorem now? Yeah, we can, right? We know two of the sides of this little triangle. We're trying to find that third. Somebody help me out, because my first step is always identifying A, B, and C for my sides. Where's my A, B, and C side for this little triangle?
C is 12.8.
Love it. Nice. Love that, Noah. Great job. Always across from your right angle is your C, your hypotenuse. Okay, so let's plug it in.
Sorry for the interruption.
That's okay.
I just wanted to bring you a donut.
Just me?
Yeah, for teacher appreciation, if you want to come pick one up.
Yeah, I do.
And we can put them in a bag for you if you'd like. We have those, so you can put it in the bag yourself, or you don't even have to take it back.
I'll just put it in a bag, save it for later. Thank you guys so much. Appreciate it. I won't eat this in front of you guys.
Thank you.
Thank you.
Yes.
All right. Okay, so we know our A, B, and C. Let's plug it into our Pythagorean theorem now. We chose x as our A, x squared, and you're like, Mrs. Campbell, we're dealing with decimals. It's okay. It's okay. Trust me. X squared plus 9.8 squared equals my C squared, 12.8 squared. Okay. Alrighty, what was our next step? What do we got to do with these squares? Can we get rid of those in some places? Yes. Let's type them into our calculator. Don't know what x is, so that has to stay x squared. But somebody type it in. What is 9.8 squared going to give you?
96.04.
Beautiful. It's okay that we're dealing with decimals, right? They're just ugly numbers that they have to follow the same rules. What about 12.8 squared? What'd you get for 12.8 squared?
163.84.
Nice. 163.84.
Well, this week.
Colin, what's my next step?
Huh?
I have this equation right here. I'm trying to get x by itself. Do I need to get rid of the squared or this 96.04?
96.0
How do I get rid of it?
minus.
Good job. Okay, we're going to subtract this 96.04 from both sides, 96.04. So I have 163.84 minus 96.04. What did I get?
67.8.
Nice, I agree. Is my x all by itself?
Yes. Oh, no.
What do I got to get rid of?
Squared.
Squared. How do I get rid of squared?
Square root.
Square root. Square root. In your calculator, you're going to do the square root of 67.8.
Which would be 8.2.
Let's round it to one decimal place. What'd you get, Ty?
8.2.
8.2. And look at that. We found that chord, that missing chord in our circle. It was 8.2. Yeah, we had to work with decimals, but they followed the same rules. You just typed them in your calculator. Might have just taken you a little longer to type a few extra numbers in there. Okay, use Pythagorean theorem, solve for that missing side. Alrighty, let's look at, what one do we want to look at? Let's look at number 10. Okay, we'll maybe do like 2 more. Do I have everything? If I'm given this little triangle in here, okay, do I have everything, or do I know at least 2 of those sides to plug in Pythagorean theorem? I know at least 2, right? Okay, so somebody help me out. Out of these 3 sides, where's my A, B, and C?
C is 16.4.
Mm-hmm.
Doesn't matter what the other ones are.
Doesn't matter what the other ones are. Why not? 6.1 will make A, X will make B. Okay? So we didn't even need to do like the whole, oh, this was equal to that, blah, 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 blah. We already have everything we need. Okay, so let's plug it in. A squared, 6.1 squared, plus B squared, X is my B, equals C squared, 16.4 squared. Alright, punch it in your calculator. A lot of calculator work today. 6.1 squared, what'd you get?
37.21.
Agreed. 37.21. Don't know what X is, so it has to stay X squared. What'd you get for 16.4 squared?
268.6096.
You got it. 268.96. Bada bing, bada boom. What's my next step to try and get X by itself? Subtract what?
37.
Subtract 37.21 from both sides. Minus 37.21. So we got 268.96 minus 37.21. What'd we get?
231.75.
You got it, you got it. And what is my final step to find this missing chord in my circle? Good job. You're like, oh my gosh, when are we gonna stop dealing with triangles? I thought we were talking about circles. Square root. We have cleared out. Okay, your little second button. Click second. And then this little x squared button, you can't really see it too great, but it has a little square root sign over it. So second, x squared button. And then 231.75. Close parentheses, enter. Let's round it to 1 decimal place. What's that gonna be?
15.2.
You got it. So that missing
Booyah.
side, 15.2. Does it give me units? Nah. Guess it doesn't care this time. Alrighty. Let's do one more. One more just for good practice.
My hand hurts.
Your hand hurts, I'm sorry. Alrighty. Okay, we're looking at this triangle, because that's the one with my X. Okay, do I have both pieces, or does it tell me right off the bat?
Yes.
Kind of. This side's 9, but what's that side?
That one's equal to 12.4.
Same as the other one, 12.4. Okay, now I have at least 2 sides of my triangle, but which sides are my A, B, and C this time?
C is X. A
Mm.
or B, C, 12.4 or 9.
Beautiful. Ooh, C's are X this time. I like this. I like this one. Good practice. Okay, here we go. A squared. Get a different color. 12.4 squared plus B squared, 9 squared, equals C squared, chose as X, X squared. Okay, let's punch it into our calculator. 12.4 squared.
153.76.
You got it. 153.76. Oh, 9 squared. We don't even need a calculator for that. What's 9 times 9? 81. Still equals X squared. Don't know what X is. Ooh, what do I need to do with those 2 numbers, you guys? Do I need to move them to the other side? No, I need to add them. They're both on one side. Just add them together. Okay, what am I going to get with 153.76 plus 81?
234.
Beautiful. Okay, so that time we didn't need to move anything. Both of those numbers were already on that side. We just had to combine them. Okay, my last step, opposite of square. Square root. Square root. Again, calculator, you're going to want to click the little second button, then your x squared button. Give yourself your little square root thing. Okay, 234.76. Round it to one decimal place.
15.3.
Got it. X equals 15.3.